Hello, my name is Islam Deeb and I am a PhD student at the University of Oulu, and today I am presenting my paper Traffic Learning and Proactive UAV Trajectory Planning for Data Uplink in Markovian IoT Models. So this paper was published in IEEE Internet of Things journal in 2024. So the recent progress in machine type communication based IoT has witnessed new service modes such as massive NTC and URLLC. Hence, the age of information, or the AOI, is defined as the time elapsed since the generation of the freshest received packet, which means that the lower the age, the fresher the information available about a certain process, and it is very important metric in URLLC applications. The deployment of UAVs as mobile relay units or base stations is considered to be appealing for remote area coverage and collecting data from low-energy devices. IoT devices require strict latency and reliability demands, which question the current resource allocation techniques. Machine learning techniques such as reinforcement learning and LSTM can plan the trajectory of the UAV and its scheduling policy for efficient resource allocation. In this paper, we consider multiple IoT devices deployed in the ground, and flying UAVs collect this information from the devices and relay the information to the base station, which located in the middle of this network. And we assume that the devices are not active all the time, and there is a traffic arrival, which is modeled as hidden Markov model, as shown in this figure. We propose two solutions for traffic prediction. First, LSTM predictor, which models the problem as time series problem and predict the future activation pattern of the devices, which means which sensors are active and which sensors are silent at a time. And we compare this deep learning model to another model called the forward algorithm based hidden Markov model, which is a classical statistical method to also predict the future activation of the sensors. Then we feed this prediction to an deep reinforcement learning model modeled using deep neural networks. And the purpose of the deep reinforcement learning model is to choose which way the UAV should move and what devices should the UAV schedule at a time based on the prediction information. And here is a summary of the pseudocode of the proposed method. So we first perform the traffic estimation using LSTM or the forward algorithm. Then we feed this activation prediction in the states for the reinforcement learning model. Then we optimize the policy and the movement of the UAVs and also the reward function for this UAV until convergence. And here are some of the selected results. So we first show the average age of information of the sensors. Then we show the regret, which means how many sensors are served when they are not active and how many sensors are not served when they are active. Then we also show the accumulative power, which depends on the distance between the UAV and the selected device to transmit its packet. And as we can see, the proposed method based LSTM achieved a very good results compared to the classical forward algorithm as traffic estimators, and it almost gets the Gini-aided behavior, which assumes that the true states of the devices or the true activation pattern of the devices is known. Finally, we show the average age and the average power when we change how much the reward function should care about the AOI or the regret or the transmission power. And as we can see also, the deep reinforcement learning model based LSTM is more efficient in predicting and in achieving better age results and better overall power results. Thank you for listening, and if you have any question, don't hesitate to contact me using this email, and also you can visit the paper using this archive link. Thank you.